used to find missing sides and angles in a triangle that's not got a right angle in it if we don't know one of the ratios. If we know a ratio, we'd use the sine rule because that's easier to use. If we don't know a ratio, we need to fall back on the cosine rule. There is the cosine rule, a squared. So it's set up to find side A. It equals b squared plus c squared minus 2bc cos A. So that means you need to know the other two sides, b and c, and the angle opposite the one that you're trying to find. So it involves the angle opposite the side you're after. So to be able to use the cosine rule, you need that angle, the angle opposite the side you're after, and you need the other two sides. If you've got that information, you can use the cosine rule. If you've not got that information and you haven't got one of the ratios, then you're stuffed really. Okay? You can't solve the triangle. Okay? So we're going to have this information. If you can't use the sine rule, you're going to have this other information somehow to get the other side. Yeah, you need the other two sides and the angle. And there's one other situation we'll look at, and that's where you've got all three sides but none of the angles, and then you would use the cosine rule but rearrange to find an angle. So we'll look at that in a second. But here it is at the moment. Now, of course, we could be after this side B or this side C. So the way I use the cosine rule is whichever side I'm after, x, will be what I'm calling A. So if you're asked to find a triangle and it says find this side here, there's x, find it, then I say to myself, right, that's side A. So in other words, I'm going to apply the cosine rule, and that's going to be x. Okay, and then the rest follows. I know the other two sides, whatever they are, and I must know the angle opposite the side I'm trying to find, and then I can use the rule. Okay. So let's look at an example. So in this example, we don't know a ratio. So I have to use the cosine rule to find x. And to apply the cosine rule, I need to know the other two sides, which I do, and I need to know the angle opposite the side I'm after, which I do. So I can use the cosine rule. And I say x squared equals the other two sides squared. So whatever the other two sides are, it doesn't matter which one I call B and which one I call C, I just square them. 11.2 squared plus 10.6 squared minus, shift it to the left a bit, let's have a bit more room, minus 2 times the other two sides, 10.6 times 11.2 times the cosine of 40 degrees. That's literally what I do, and then I just put that into the calculator. So if you do that, now there's one problem with this. What is 55.9 telling us? Yes, it's telling us x squared. So a very common error is to forget to do what? Square root it. So x is actually the square root of that. Which is 7.47 or 7.5 for two significant figures is probably appropriate. Oh no, we've got 3 there. So 7.47. 3. To save making the mistake of forgetting to square root it, you could write the cosine rule like this. A equals the square root of all that lot. So going back to our example, we could have written x equals the square root of 11.2 squared plus 10.6 squared minus 2 times 10.6 times 11.2 times the cos of 40. And then hit equals and you get the answer in one go. In a lot of ways, the cosine rule is quite simple. There's the formula. You don't have to worry about ratios and inverting the ratios and all the rest of it. the thing is, you need this information to be able to use it. You need the other two sides and the angle opposite the side you're after. If you've got that information, you can use the cosine rule. If you've not got that information, hopefully you've got one of the ratios, so you can use the sine rule. Okay. So here's the other situation where we'd use the cosine rule. We know all the sides, but we know none of the angles. So obviously we don't know any of the ratios, we haven't got any of the angles. But we can use the cosine rule to find an angle. However, that means we need to rearrange this cosine rule for the angle. I'm not going to ask you to do that. So to use this, we rearrange the cosine rule for angle A. I'm going to just give you the formula rearranged. If you want to, as an extension activity, you can try and follow the algebraic steps, which aren't that bad actually if you just take it slowly, and you should be able to arrive at this formula. So try it if you're interested. A prime, well, let's put it in a different colour. So this angle A turns out to be the inverse cos, we're after the angle whose cosine is. I need to just see it to be able to do it. So it turns out to be, so that over there, so to b squared plus c squared minus a squared, b squared plus c squared minus a squared all over 2bc. There is the formula written, rearranged. Note when you're using this, that if we're referring it to this problem, what is angle A? That's important. So if we go back to our example, if I'm going to say call this angle A, then the one opposite is side A, so that's the one that in this formula is minus. Okay? It doesn't matter about the other two sides, you just add them together, but you subtract the side that's opposite the angle you're trying to find. That's the only place that you might slip up. So for this example, A equals the inverse cos of b squared, which is 8.5 plus 6.8, so it's the other two sides squared, minus the side opposite the angle squared, all over 2 times 8.5 times 6.8, close bracket. So again, you can do that in one hit on the calculator. Have a go. So 55 degrees, hopefully. Okay.